Hey guys, so today I'm going to go over the details on how I made this oxalic acid vaporizer. So what's special about this unit that I put together is this entire unit was made with the material that was already available in the market, and there was very little fabrication was needed making this whole unit. And specifically, I did not have to have an access to a lathe, a welder, or welder's torch. Um, I put together this unit using the material or the tools that most of us would have uh, in our garage. Also, some of them who try to put together this kind of unit had trouble keeping the heat mass in the cook part. So when the oxalic acid hits the cook part, it drops the temperature so much, and it doesn't sublimate. But I came up with this design that holds up all the heat mass that you need for this operation and stick together. So I will go over the details on how I made this cook part. So let's go from back to the front. First of all, this is the power cable, and you can get this from Home Depot, but I had a power cord laying around from a broken jigsaw, so I used that. But you could get that from Home Depot, a blank power cord. What you see here is a cable gland. You can get that from Amazon. They looks something like this. So this is a couple different pieces, actually a few different pieces here. What's inside of this is a electrical conduit. It's a metal conduit. You can get that from Home Depot. They are in the electrical section, and it's 1/2 inch outside diameter, somewhere in 3/4 inch. So what I did was I got a poly pipe. It's 3/4 by 2 feet, and I cut to the length here, and then I heat up this poly tube and then fit it into the metal tube inside. Once I got that done, and then you want to cut this a little longer so you can fit the cable gland on the back of it. So you heat this up and then tap it with the hammer, get that in. So you got a little longer piece left once you fit that into it, and then you're going to heat that side up, then fit this cable gland right inside of it. So that's what you see right there. And then what's going on here is it's two nuts, can also be purchased from Home Depot. They're also in the electrical section, going one from the inside, the other one from the outside, that basically hold the handle into the chassis. So now let's go over the chassis and the reasons behind what's going on with the chassis and the design itself. What you see here, this blue stock, is this. This is 1 inch by an 1/8 inch stock, steel stock. You can also get this from Home Depot. So you're gonna need to drill a few holes in here. The first one is right here. That's for your handle. You're gonna need to drill somewhere around 3/4 inch hole. I did not have a 3/4 inch drill bit. What I had was 1/2 inch. So what I did was I drill a 1/2 inch hole in it, and then I use a round file to make it a little bigger, and then I use a Dremel tool to make that hole the size that I wanted it. And then 2 holes here to fit the box, the electrical box. And then there's another hole right here I put there because this will reduce the heat transfer that was going on from the cook part into the electrical part in here. It's very little, but it's a safe practice. That's why I put that hole there. Also, there's another stock that I cut and then I put it across that also holds the unit once you put it on the ground or on a table somewhere. That also absorbs some of the heat that's going from the cook part into the electrical part in here if that ever happens, and plug it on for a long period of time. And that's why I did that. And then you have another hole drilled on the front, that's to hold the cook part. So the next part I would like to talk to you about is the PID unit. What I used was Auber, if I pronounce it correctly, AUBER, and the model number is 2342. The reason I used this PID, there are other PIDs available in the market. The reason I used this one because of 2 reasons. One of them is the relay is already built into this PID, so I don't have to do extra wiring. The other part is I already had this box and I was looking for a PID unit that's already could fit into this box, so I don't have to purchase this again. But putting this together, I mean, this was really tight inside. So if I would do it again, I probably would use a bigger box. And then again, if I use a bigger box, I'd probably be able to save a few bucks on buying a cheaper version of this PID unit. And then I put a switch in here that I also had laying around from the same jigsaw that I had that I used this power cable from. So I thought it was a good idea to have a on and off switch there. I can turn it off when I need to turn it off. So let's go over what's going on inside of this box, what the wiring would look like. This is the manufacturer's wiring diagram. This PID unit has numbers in it, so it's pretty easy. 4 and 5, that's where the thermocouple fits into. 4 is positive, 5 is negative. And then on this side, 9 and 10, that's 9, that's the hot wire, and then the 10 is the negative. And then you need a jumper from 9 to 8 right there. And then the heater connects into number 7 and number 10. And that's all what's going on inside of this box. So let's go over the electrical box and how the cables goes into the box. First of all, I drilled 2 holes to match the holes I already drilled on the chassis to fit the box. And then I raised the electrical box by putting 3 washers before I put in the nut in. That to reduce the heat transfer if that happens, going from the cook part into the chassis to the electrical part. So that will reduce that risk. And then what you see here, I drill a hole to fit the cable gland in so I can tighten the 2 cables goes in from the front. One of them is going from the band heater, the other one is from the thermocouple. And in the bottom here, that's another cable gland to hold the power cable goes into the electrical box. So that's also been tightened. That's about it for the box. So now let's go over the cook part assembly. There are several pieces into this assembly. So let's start from the top. So this is, it's a heat resistant rubber cap. What this is, 1.5/16 by 1.5/8. You can buy this from Amazon. It comes in a package of 5. So I used those rubber caps to make 2 parts on the cook part assembly. The first one is to hold the oxalic acid. So I drilled a hole with 1/4 inch first and then went on to 1/2 inch. So this hole you see here is bigger than 1/2 inch. How I did it was I used utility knife, cut it off little by little, and then brought it back to the drill press. Used the 1/2 inch drill bit to smooth that off. So that goes onto the top. And then the bottom here, I took another rubber cap and I cut it into a length. Put one piece on the top and the other piece on the bottom. So this actually does three things. One of them is it would give some flexibility to your cook pot, because you're gonna insert this into the beehive, right? So once you insert into the beehive, sometimes it hits this somewhere, and whatever that happens, so that shock might have break the connection that's going on to the cook pot. The sprout might break, or the connection might get loose. So if this is flexible, the chances are low that would happen, right? So that one of the reasons. The other one, this would reduce the heat loss from the cook pot. So that takes care of that issue everyone was having, not keeping the heat mass on the cook pot. The third reason, it will reduce the heat transfer from the cook pot into the chassis. So those are the three reasons I used heat resistant rubber for that. I used this oxalic acid vaporizer on my beehive, and it worked. So there's two electrical parts goes into the cook pot assembly. What you see here, this brass piece, is the band heater. This one is 42 by 50 millimeter, 110 volt, and 380 watt. And this is plenty strong enough to do this operation. And then there's a thermocouple. The thermocouple reads the temperature that generates from the band heater. The thermocouple I purchased from the same company that I got the PID unit from. So now let's talk about the inside of the cook pot. What you see here, this piece right here. That actually is few pieces. One of them is you need 1.5 inch by 1.25 inch brass stock. You need to get a 1.5 inch brass stock and then cut it to the length. So now you have 1.5 inch by 1.25 inch brass piece to fit inside this pipe. Once you cut this brass stock, then you need to drill 2 holes. Those holes are 1/4 inch by 20 thread pitch. The one in the middle is to hold the cook pot assembly into the bracket. This nut, that for the middle one. And then you need one outside one for the thermocouple. That thermocouple also has a thread pitch of 20 and it's 1/4 inch. So that's what's going on inside to this brass. This is copper coupling. Okay, so this copper coupling, what you see right here. Now, in order to make this piece, you actually need 2 of these copper couplings. This is 1.5 inch by 1.25 inch. So it basically 1.25 inch pipe goes into 1.5 inch pipe, so to say. So you take two of these couplings and fit this side on the top of this. So you have two pieces. So I have only one here, this copper coupling. And then imagine this is inch and a quarter. What you're going to do is you're going to heat up the 1.5 side significantly and fit it onto the other piece. And then use the hammer to push that in. So eventually you will have a piece like this. That is to do a couple of things. That heat mass everyone was having problems with, that will solve that problem, because you have enough thickness here. Once you join these two tubes together, also it will help you on the next step where you're going to fit the sprout into the cook pot, because now you have much thicker wall goes into the sprout. Now you don't have to weld it, you can just thread it. Once you get that done, now you need to fit this brass stock into the copper coupling. So inside diameter of this copper coupling is 1.5 inches. Outside diameter of this stock also 1.5 inches. So you're gonna need to file the inside of this copper coupling a little bit and then rough fit this brass stock into it. Once you do that, you're going to hit this side up and then refit this brass stock into the coupling. It will go in there. You will see that in the next clip. So this is the cook part. I got the 1.5 inch brass stock here fitted into the coupling, the copper coupling, and then drill 2 holes, one to hold it into the frame, the other one is for the thermocouple. So this came out a little loose, fitting into the copper coupling. So I drilled a hole. Basically, I put it into the vise and made it tight as much as I could. And then I drilled a hole in there, to tap a hole into it, quarter 20. And then I was going to fit this into the heater, and it came out tiny bit bigger because of this brass coupling nut here that basically holds it from closing all the way down. So what I did was I cut a small piece of sheet out of a coconut milk can and then fit that right into the heater, so it basically fill in that gap. So the final part is to fit this output tube into the cook part. This part is pretty easy. It is actually 4 parts. What you don't see inside of this clamp is a coupling with a nut. This one is a little different from what I used here because the thread count is a little different on this one, this particular nut. It's a coupling. What you want is 27 thread pitch nut on the both side. And you're going to drill a hole on your cook part, then thread that into it, 27 thread pitch. Once you get that done, thread this nut into the cook part, like you see it here. This one is a hex nipple. It has a thread in it, also 27 thread pitch. And this one is a nipple, the same amount of threads, and that goes into the hex nipple. And what you see here is an end cap that to close everything out when not in use, so spiders and things don't get in there. What you see there is a clamp. It's 2-inch clamp. I just put it over the output tube, and it also clamps into the band heater. So this will make it even tighter grip fitting into the cook part. And that's it. So the next part is to bring this outside and do a test run. So it will take about 6.5 to 7 minutes to get up to the temperature. My set temperature is 230 degrees Celsius, but this unit will shoot all the way up to somewhere into 50s. At that point, you're ready for your sublimation. So let's get it started. So I'm going to turn this on. At the same time, I'm going to turn on the timer. So it's right here. Okay. Now wait for 6 minutes and then, well, 6.5 minutes. So it shuts off the band heater. Actually, it's about 5.5 minutes. Now you're ready for your sublimation. temperature start dropping right now, and it should be ready by now. So, so thanks for watching, guys. It was a fun project. It took me a little while to put everything together. I hope you guys enjoyed the video. So I used this unit on my bees. I did 3 weeks of oxalic acid treatment with 7-day intervals. The first time I did the treatment, I saw large number of mites was dropped into the sliding board because I have a screen bottom board. And the second time, there wasn't that many mites fall into it. And the third time I did the treatment, now I don't see any mites falling into the sliding board anymore. So I'd say it's close to 100%. So check that out. Do your own judgment. And thanks for watching. If you haven't subscribed to my channel, please do so. And if you like this video, give me a thumbs up. And until the next video, take care, you guys.